learners, you're welcome to Eko Learners Support for WAEC and NECO candidates. Once again, I'm Kamaldin Abiona. So I'm to take mathematics, and for today we are looking at Venn diagram in explanation of sets. Okay, so let's go.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Alright, so sets and Venn diagram. We have looked at set before. We have defined set as collection of well-defined objects. And today we want to look at how we can bring Venn diagram to solve problems on sets. So we explore how Venn diagrams can help us visualize and solve problems related to sets. So Venn diagram are visual representation of sets, allowing us to easily understand relationship between different types of sets. Okay? So we have defined sets before. We have talked about notation of sets, set notation. We have also given examples of sets, and we have mentioned cardinality of sets. That's number of elements in a set. So in Venn diagram, we'll be making use of cardinality of sets. All right. So like I mentioned before, is the visual representation of sets. That is Venn diagram. So Venn diagram, every set will be represented with a circle. And the whole of the universal set, we represent it with what? A rectangular shape. All right, so, okay, key components. Venn diagram, we have circles, like I've mentioned. So if you have more than one set, if you have two sets, we can have overlapping circles. Sometimes if they are disjoint sets, I'm still going to mention disjoint. When we say disjoint, remember we have mentioned intersection of sets before. Yes. So when the two sets, when there is no intersection between them, then we talk of disjoint sets. So that is also one of those things. We have mentioned universal sets before. So how do we represent that in Venn diagram? It's part of what we'll be talking about in our next. So elements in a circle, in each circle. So these are elements that belong to only the set represented by that circle, circle A. So element of overlapping, when we have overlapping area. So the area that belong to both, just from the definition of concept of sets, we have intersection of sets. So which is element that is common to two or more sets. And we also have area outside. So which, okay, so the region here, like I've explained earlier, elements only in set A. So this is combination of two sets. So we have set, this is set A represented with this particular circle. We have set B, and the region here is element only in set A. This is element only in set A. Region 2 is element only in set B, element only in set B. And we have region 3, which is both sets. That is the intersection, the overlapping area that I mentioned earlier. Then we have region outside, which is the region that is that does not belong to A and B. So in set, we use A union B complement for that. Okay? This we use A intersection B for that. And here, this is A only in set notation. Can you guess how do we write that in set notation? A only. It means A but not B. A but not B. Not B is B complement. And this region, which is A only, B only, it is what? B but not A. All right, so that is the areas or the regions. Okay, so this is from what I've explained. We can find that here. Okay, so this is set A, the first one. First diagram there, set A, which is the green area. the green area, set A. Set A, you can see only the green, only the circle A has been shaded. A complement, it means outside A, not A, not A. So A is shaded white, and the whole of other region that is not A shaded green. Okay, this is A and B. I mentioned disjoint set. What do you mean by disjoint set? Meaning the intersection of the two sets is empty. Intersection of the two sets is empty. You can see that. I've also mentioned subset in the last class, subset of a set. It means B is a subset of set A. It means all elements in B also what? Belong to A. So that is B is a subset of Then we have intersection, which I've mentioned. You have defined that before. So this is just for you to recall the definition. So in Venn diagram, both A and B, that is A intersection B, that's the green area. We also have what? A union B, which is all the area that contains regions of A or B, either A or B. So that's another. Okay. Now let's see how we can draw a Venn diagram. An example is here. Suppose we have two sets A, 1, 2, 3, 4. Set B, 3, 4, 5, 6. We want to find the intersection and the union of the what? Of this set using a Venn diagram. So let's use a Venn diagram. We need to illustrate it in Venn diagram. From this is our A. Okay. Draw two overlapping. Draw a Venn diagram. That's the step. Start by drawing two overlapping circles. Two overlapping circles. Okay. So label one A and the other B. All right. Fill the element. Okay. Now in filling this, the first thing you do is what? The intersection. You fill the intersection. What's the intersection between A and B? What is common? 3 is common. 4 is common. So fill that first. 3, 4. Wow. That's great. Then the next thing is what? Identify the intersection which you have done and then look at those elements left. Now pick circle A. What are the elements in A that are not in the intersection? So we have 1 and 2 left. So this is 1, 2. The same thing to B. We have 5 and 6. 5 and 6. Okay. So with that, you have been able to what? Draw the Venn diagram using that. Question 2. The same question, but here it has been done in what? Cardinality. 15. And we have what? 12. Number of A is 15. Cardinality of B is 12. And cardinality of A intersection B is 5. So we want to find the number of A union B using Venn diagram. So like I mentioned, draw the Venn diagram, two overlapping circles. Okay, this is A and this is B. All right, number of A is 15. Number of A, you can write it up here, 15. Number of B is what? Number of B is 12. Number of B is 12. And the number of intersection of A and B is what? 5. So this is that. Now, so we have filled the intersection. Then fill the remaining elements. The remaining elements. We have number of A is 15. 5 of them is here. So 5 are here. So it means the remaining one will be 15 minus 5. Okay, this is 12 here. For B, we have 12. So B only will be what? 12 minus 5. All right. So with that, and this is 10. This is 7. So the question is find union, the union. When we say the union of sets, the union of sets means merging all of them together without repetition. So let's merge. Number of A union B, A union B. So it means we merge. We have 10 elements here. We have 5 elements here. And we have 7 elements here. So, and that is what? 22. All right. So the number of elements in A union B is what? 22. All right. Do you get that? All right. Thank you. So let's go. We have another question here. In a class of 40 students, 25 students like mathematics, 20 students like science, and 10 students like both. How many students like only mathematics? So let's see how we want to apply a Venn diagram to solve this. Now, in a class of 40 students, how do you represent that? Wow, that's great. That's the cardinality of what? The universal set. Cardinality of the universal set. This is the universal set, remember? So that is 40. 25 students like mathematics. So we can say let M represent mathematics, use M to represent mathematics, and S to represent science. So cardinality of mathematics. Number of elements that offer mathematics is what? 25. And cardinality of science, number of students that offer science, is 20. Thank you. Then students that offer both subjects. How do you represent that in set? Wow, that's great. So number of M intersection S. And that is what? 10. Thank you. Okay, so how do you represent that in Venn diagram? Draw a Venn diagram with 2 circles, one for math and one for science. Okay, let's do that. Two overlapping circles. Okay, this is math and this is science. All right, so the first thing you represent or you indicate there is what? The intersection, which is 10. Good. Then from there, what's the next thing? Number of mathematics. We have 25 students offer mathematics. And out of the 25 students, 10 are also offering science. So it means you subtract. When you get to mathematics only, those that do mathematics only will be 25 minus 10. Science only will be what? 20 minus 10. 20 minus 10. Wow. So mathematics only is 15. And science only is 10. Wow. So that is from the question. It says how many students like only mathematics? Like only mathematics. So it means that is 25 minus 10 because 10 students like both mathematics and science. So 15. So the question, number of students that like both mathematics only, mathematics and not science. That's another way we write that. Mathematics, but not science, not science. And that is what? That is 15. All right. So I think with that, we can now look at the conclusion. We have looked at Venn diagram as a way of visualizing our sets. And we have also been able to use the operations of sets in Venn diagram. So we have also used Venn diagram to solve so many problems, like the last one we did. So before we go, let's take these practice questions. In a group of 50 people, 30 like apples, 25 like oranges, and 15 like both. Use Venn diagram to answer the following questions. How many people like only apples? How many people like only oranges? And how many people like neither apples nor orange? So just use that concept. We have just 30 seconds to look at that. You are welcome back. I hope you got that. Yes. Okay. Fantastic. So let's look at it together. Question: in a group of 50 people, so write that out. Number of universal set. Cardinality of universal set is 50. Okay. 30 people like apples. Number of apples. Those people that like apple. 30. 25 like oranges. Number of oranges. Use O for orange. 25. And like both, we have 15 like both. So meaning number of apples and oranges. Those people that like oranges and apple, they are what? 15. All right, so let's draw a Venn diagram. Remember the steps? Draw the Venn diagram. Okay. And the Venn diagram, we are drawing two overlapping circles. Yes, two overlapping circles, because we assume there are some that like both apple and oranges, and they have given us. Okay, so let this be apple, this be for oranges. All right, so let's indicate the first thing, that is the intersection, okay, which is 15. All right, so after that, the next thing is look for those that like apples only and oranges only. Apples only. The whole of apple is 30. Now, 15 of them also like oranges. So, for apple only, we have 30 minus 15. And that should give us 15. Oranges only. That is 25 like orange. And 15 of them also like apple. So we have 15, 25 minus 15. And that is 10. All right. So the question, let's go to the question. How many people like only apples? Only apples. And that is what? 15. Okay, did you get that? Wow, that's good. So 15 for that. How many people like only oranges? Only oranges here. And that is what? 10. Okay, that is 10. So how many people got that? Wow, that's great. And the last one, how many people like neither apples nor oranges? Yes, neither apples nor oranges. So where do we find that? It means outside the two circles. Outside the two circles. Outside. Do we have anything outside? So how do we get that? Go back to the information. Number of universal set is 50. 50. Everything inside this box must give us 50. Let's add up and see whether they are up to 50. This is 15 plus 15. That's 30 plus 10. That's 40. So it means we have 10 people missing. So it means they must be what? Outside the circles. So you can find them outside here. You can write them here or here, anywhere, outside the circles. So how many people like neither apples nor oranges? That's what? 10. Yes. I hope with this, you should be able to practice more.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
If you have questions, comment, so you can make use of the link on the screen. Thank you very much.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.